All right, welcome back. We are COMP1011, that's Advanced OOP with Java, and in at Georgian College in the summer 2022 semester, and it's week 2, part 1 of our broadcast and recording. And what we're going to be doing right now, very good. What we're going to be doing right now is just talking about what we did last day. So last day, what we did was we talked about some basic recommendations for how to do well in the course. We discussed the syllabus and the course outline. We also did share the Discord server with you. I know that most of you have joined at this point. We discussed lab reports and their importance and how to do them. And I think the people that submitted your ICE 1, for those people, thank you very much. Most of you did it well. Some of you didn't. We'll talk about that in 1 second. And we also have two things. There's assignment videos and ICE videos. And for your ICE video, I think, like I said, most of the time we talked about how to do them. I said you can use any streaming service you want. Some people used Microsoft Online. Some people used OneDrive. Some people used a bunch of different things. The main thing was that I had to have your video available to me, so I had to be able to see your video somehow. It had to have volume, and I had to be able to see it. If it didn't have volume or I couldn't see your screen, I gave you a 0, and the reason for that is because, well, I can't hear you, I can't see you, it's not a video for me, right? So that's the one thing I did. Lab reports, again, if you didn't include one, you got a 0. If you did include one and it was empty or not marked properly, you got a 0, like I said before. But for the most part, I would say 90% of you did it correctly. You submitted the lab report and the video. Sometimes you also submitted a Git repository, and the Git repository was inaccessible. Remember that, I'm just going to put this in the chat here, you need to add me, my last name, at hotmail.com. That's the one I'm using. And I've just put it in the chat here, as a collaborator, no one else. Don't look me up and look at just my last name, or you put my first name, last name. You'll get somebody else. That's not me. That's not the me that I want you to use. I want you to use this one, and it's the one that I put inside of your in-class exercise 1 instructions on Blackboard. Okay, if you didn't include me properly, or you didn't include me at all as a collaborator, or you didn't include me as a collaborator on your video, let's say you shared it on Google Drive or something like that, and I couldn't access it for some reason, so you didn't give me access, then you got a 0. Okay, that's the kind of stuff that you did. Or if you didn't include me as a as a collaborator on GitHub, you lost 0.5% of your final grade. All right, that's how it works. Okay, so it's pretty simple. Follow the instructions and you get full marks. If you don't, then you lose whatever you didn't do properly. Typically is how I do it. Most of you, like I said, 90% of you did it well, and it's all marked. Some people didn't submit, and there's a reason for that. Some people didn't submit because you weren't here last week, and some people didn't submit because, well, you didn't know how to do it, or you ran out of time, or whatever the reason was that you didn't do it. But remember how I'm evaluating you, even if you messed up this one. Okay, so I'm going to give you the best 10 out of 12 in-class exercise. So even if you messed up your in-class exercise for last week, it doesn't matter, guys. The great thing about that is that you're going to have a chance to do it again and again. You can mess up twice, and you're still going to get 100% on your lab exercises. So don't worry. Don't sweat about it. Even if you missed last class and you missed last week, it doesn't matter, because you can still do 100% from here on in. Okay? Any questions around the way I'm evaluating you? So the best 10 out of 12 is what I'm doing for in-class exercises, which count as little tests to do what I'm doing in class. It's kind of like a lab, but it's like, something that I'm testing you on a regular basis. This counts as like a little quiz, and all you have to do is basically follow instructions and you're good to go. Okay. This week I am releasing assignment 1. The details I will record. You'll have up on Blackboard tomorrow for all the details. There'll be a small recording on it, what I'm looking for and all that. Plus there'll also be an associated lab report that's going to mimic the rubric for assignment 1. For assignment 1, you'll see you'll build a small user interface, and it's going to be very straightforward in terms of what I'm doing. Assignment 2, you'll add more functionality, to what I'm asking you to do. So assignment 1 and assignment 2 are kind of one big assignment. Like I said, they're worth 20% combined, but there's 2 parts to it, part 1 and part 2. And again, if you watch the video for tomorrow, which I will post later on or in the afternoon tomorrow, you'll see all the details that you'll want. And I'm going to obviously take questions and all that kind of stuff next week if you have any, but please watch the video that I'm going to post tomorrow. Let's see how you do on that one. So that is what's happening this week in terms of stuff. We're sitting at week 2, so that's the week of May 16th, to the 20th. That's the week we're sitting at. We're going to review JavaFX today, and you can see that ICE 2 is going to happen. It's already posted, and it'll be due on Saturday. Again, the lab report will be updated either later tonight or tomorrow, and you'll be able to submit by Saturday. But if you follow along for the most part today, you'll see that you'll have everything that you need for the for your in-class exercise for Saturday. It won't be something that is going to be completely out of whack. And you guys did exactly what I asked you guys to do. The people who submitted properly, and you got full marks. The great thing about that is, there you go. The great thing about that is that you got full marks based on the fact that you followed along and you did what I asked you to do. Okay, this is the great thing about this, right? So, and this is good. This is good news. And actually, to be honest with you, I'm really surprised at how good some of you did. Some of you had great videos. Some of you had videos that, used your faces. You don't have to show your face, but someone did. Some people went the extra mile and did that kind of stuff. Very detailed and so on. There are some people that went a little bit over. Please try and keep it within 1 to 2 minutes because it is an in-class exercise. It's not something that's really massive or whatever. But I think really, you guys really did a great job for the most part. So I'm really surprised and happy about it, to be honest with you. So that was really, really good. Next week, we're going to be doing more of JavaFX. That's coming up, right? So that's what's happening next week. And we're also going to be doing JUnit testing. That's coming up, as well as accessing databases with JDBC. And you're going to need that for your assignment 2, if I'm not wrong. All right, so that's coming up. And then following that up until midterm, again, you're going to have a midterm practical test that I'm going to ask you to do. Everything that we do every single week is going to build you up so that you can be successful for your mid-semester test, again, which is going to happen on week 7. So that's the week of June 20th. Okay, that's I'm just going to kind of updating the schedule for you guys, just reviewing the same stuff we talked about last week, just in case you missed it. All right. Any questions or concerns from last week? Again, the reason why I'm asking this, guys, is because just want to make sure that you guys are good to go, that there's no issues and all that kind of stuff. Okay, awesome. Thank you so much for that. And you know what? Like I said, for many of you, because you haven't had me as a professor before, this is a work in progress. But for most of you, right, you guys, like I said, really kind of hit it out of the park as far as I'm concerned in terms of what you did for me for the in-class exercise. Do that again. Whatever. If you guys got 3 out of 3 last week, keep doing the same thing that you did last time. And you're going to be perfect in this course. You're going to be great. And good practice for you as well. All right, so that's where we're sitting from last week. This week, what are we doing this week? So we're going to review JavaFX like we said. We're going to talk about MVC, so ModelViewController. You guys should know ModelViewController a little bit. We're going to design and implement the MVC design pattern in Java with JavaFX. We're going to do that. We're going to launch a JavaFX scene utilizing multiple objects. We're going to be talking about that. And we're going to use the JavaFX scene to instantiate a custom class, which is kind of what we're doing with our Vector 2Ds this week. We're going to continue using the Vector 2D example from last week. This week, hopefully we'll be able to do that without a hitch. We'll see how it goes as we go forward. We're also going to utilize some simple exception handling, and so that way we have a good experience for our user. That's what's happening. So let's move into this part. So JavaFX review. So one thing is that you can always get some great from Open Java JFX. Actually, is an Open JFX project that's out there, which is really interesting, which details most of the same stuff that you've learned already if from the textbook from JavaFX, the first time you kind of hit JavaFX. And again, I'm just going to put it out there to you guys. My expectation, and I'm going to say this to you guys now, I'm hoping to get some feedback. My expectation from you guys is that you have somehow done some JavaFX in the past. Yes? What are your thoughts? And you can put something in the chat, or you can use some kind of emoji or something like that if you like. What are your thoughts, guys? Yes? Did you do JavaFX in the past? Yes, I see some yeses. That's good. So it's not going to be something completely new. Okay, it's not like you've never used JavaFX before, and now suddenly, we're introducing that. We're not doing that. This is something that you've seen before, and, we're going to just make you work with the same structure that you had before. The great thing about this is, like I said, there's some great projects out there, like the OpenJFX project, that gives you all kinds of details in terms of how to build interfaces. The great thing about JavaFX is it's open source, and you don't need to use it just for the applications we're using it for. It's cross-platform, and it's something that you can use in other applications. Mostly it's for Java though. We're also going to be using Scene Builder today. So one thing I asked you to do last week was download and install Scene Builder. So hopefully you've done that. And has anyone not done Scene Builder, not installed Scene Builder from last week? Hopefully you have. If you haven't installed Scene Builder, or if there's anything you haven't installed from last week, please go back to the videos. Thank you, Aditya. And please go back to the videos last week, the video I made last week for installation, and go and do those installations before you do, kind of the stuff that we're doing today. Because you need to have Scene Builder installed in order for us to be effective with what we're going to be doing today. Okay, so that's what's happening with this. Okay, and one thing that we're also going to be using is we're going to be talking about Fxml a little bit, but we're not actually going to be doing Fxml by hand. We're not going to be using Fxml by hand. Maybe not at least not in this class today. Maybe we'll get to it in a future video, but for the most part, Fxml kind of looks like XML, and what it does is it describes, it's very declarative, and what it describes is your interface, what it's going to look like. The great thing about Scene Builder is it's going to create Fxml and add all the classes and everything else we need for us, so we don't have to do a lot of that work. A lot of times, JavaFX has not been bundled alongside with Java. You have to kind of select the special template that we're going to go into in a second. Back in IntelliJ, we're going to see that you have to select a different template, and when you do that, it adds in all the new things, all the packages and everything else you need for JavaFX to be part of your project. Right, so it's kind of a different project than what we worked with last day. If you remember, last day we kind of started off with a brand new Java project, and today we're going to do a JavaFX project, a totally different project than what we did last day. So that's kind of what we're going to be using. We're going to be using Fxml, but it's really going to be generated for us. In your lab report, there might be a section that says something like add an Fxml file, because you need to add an Fxml file in order for a Scene Builder to target it, and we'll see that in a second. And so it can add all of its code, the generated code, for you instead of you doing it manually. You don't want to be able to do this manually for some of the stuff that we're doing today. Okay, so that's kind of what we're doing. The other thing that we're going to be talking about with JavaFX, and let's review some of those things. We're going to be adding some controls. Typical controls are labels, buttons, and text fields. Those are the basic things that we normally have. And there's other kinds of controls we're going to be talking about today in the PowerPoint document. There are sliders. There are image views. There's other kinds of controls that we can also add in there. But for today, we're going to stick with those three: labels, buttons, and text fields. That's kind of where I want to go with. Again, it's just going to be a warm-up for JavaFX, get you guys going with the project structure and everything else. We're also going to work a little bit more closely with our utility class, as well as I'm also going to be talking about working with your Vector2D class a little bit more, adding some other functionality and those kind of things. So really controls, those are the ones we're going to add. So that's part of JavaFX. The stage is a analogy. Really, that's what it is. What they've done, and again, there's a previous version of a windowing system, AWT, that was used back in the day with Java, and they had this analogy for actors on a stage. So if you ever gone to the theater, as an example, there's a stage. Well, in our case, the stage, the window represents the stage, and on a stage, if you're going to go to a theater, there are different scenes. The scene comes in, there's some actors that do something, and then when the scene ends, the curtain closes, and then there's another scene, typically, right? Well, each scene is almost like a screen, if you will, okay, for your application. So in the window, you might have multiple things that are happening. Typically what we have is for each, the stage contains only one active scene or screen at a time, if you will. And what it also has is something called a scene graph, which is pretty cool. So the scene graph is a hierarchy of objects, of user element or user interface elements, right? UI elements. There's a hierarchy of objects. Some of them are they're all nodes. So all user elements or user interface elements that are on the that are displayed in JavaFX are nodes, and there's different kinds of nodes. There's nodes that are UI elements, and there are nodes like controls, and there are nodes that are layout containers, and layout containers are special nodes that also have children. So almost like a kind of a group of other nodes that are inside them. Okay, so this is how it works. Okay, so you have like kind of a root node or a parent node, and the parent node for nodes that are inside of layout containers, as an example, that means if layout containers have children, and each child, the parent is the layout container itself. Different layout containers exist, such as a VBox, which is a vertical box, an HBox, exactly, an HBox, which is a horizontal box, a stack view, and so on, and a bunch of different kinds of things that you can use. And we're going to be experimenting with some of these today. Right, we're going to use some containers. We're also going to talk about, kind of an anchor view and so on, and a bunch of different things that we're going to be using today. So layout containers are just nodes that have children. Event handlers, that's also something else we're going to be dealing with. An event handler, it uses something called the observer pattern at a very high level, and we'll talk about design patterns a bit today as well. And really, when we think about it, the event handler, we add a method, so when a user interacts with a control, then as soon as the user interacts with any control, it generates or raises, we say, an event. And this is the same pretty much in any user interface that you ever use ever. Okay, so whether you're using Android or JavaScript, or whether you're using, I don't know, Swift for iOS or whatever you're going to do, they all raise an event, and an event is generated by some kind of user interaction. So there are two parts to the event: the listener, so I'm listening for that event to trigger on that particular control, and some kind of handler, and the handler is typically a method that responds to that event. So when a user clicks on something, it raises an event, and then we're listening for that event to occur, and when it does occur, a method triggers. That related method triggers to, respond to the event. Okay, so that's what happens with an event handler. And again, this is all review. And a control class is something that we're going to be using. The controller class is allows us to connect with Fxml and allow us to, interact with the user interface and respond to any events that occur. Okay, that's kind of what we're going to see today. So this is kind of a very high level view of all the different things we're going to touch on today. So when we look at hierarchy in Scene Builder, it kind of looks like this. It kind of looks like you have some kind of VBox, and inside that you might have a label, and then you might have inside of the VBox you have an HBox. You can have multiple containers layered inside of your hierarchy, and you can see that, like we said before, the image view is a child of the stack pane, and the stack pane is a child of the VBox, and VBox is a child of the HBox, and HBox is a child of the other VBox, and so on. And so you can see that there's a hierarchy. This is typically what we call a scene graph, okay, where we have a hierarchy of nodes within nodes, okay. Yeah, I would say so, Nitin. I would say a callback function is kind of the same thing. When we think about an event handler and an event listener, the event listener is one part of it. Okay, we have some kind of event queue as an example, and then that event is raised. It's kind of put onto the queue, and then we use an event handler to respond to the event that occurs. Okay, so that is the scene builder, the hierarchy in the scene builder, and there are different things we're going to talk about. I'm not going to go through them here, but I've put them inside of your PowerPoint document just in case you wanted to see what they would look like. Both, a couple of things, examples of what they look like. You also see inside of the PowerPoint a link to the documentation, right, on docs.oracle.com. So this is kind of really neat. So you can actually go to the documentation and get examples of labels, of buttons, of text fields, of image views, of combo boxes, and so on. A bunch of different things here, right, that I've included in the PowerPoint, sliders and so on. And these are all the things that we might need, some parts that you might need for your assignment number 1. And we'll talk about that again in my video that I'll put together tomorrow. Okay, so that's what I'm going to do for you. So questions about, just high level, questions about JavaFX. Is there anything new that you haven't seen before? Or if you've never used JavaFX, then some of this might be, you know, kind of a new concept. But for the most part, I think you'll see that it's exactly the same as what you've talked about in the past. And if you've done any kind of user interface programming before in any platform, everything is very similar. Things to note, okay? Let me just, before we move on to the next piece, things to note about user interface, kind of programming. Number 1, and first and foremost, I would say, is remember that 90% of what we get from a user interface, I would say 99%. If we get text input from a user in a user interface, it is a string. Okay, that's the most important thing. Which means if we're going to get text input and I need to do a calculation, like I'm going to ask you to do today, right? We need to convert it from a string to an integer or a float or whatever else we need to do. So again, anytime the user enters any data on the interface, we need to validate what they're entering because they can enter whatever they want. Okay, that's the most important thing to note. So we'll do some validation today and we'll do more as we go forward. Okay, but that's kind of one thing to note. If there's a common saying, it's a funny saying for me, but a common saying is, all would be awesome if it wasn't for that darn user. Right? I mean, I always find that pretty funny because for me, when I think about it, without users, we really don't have any jobs. But, we always complain about that darn user. We're always thinking like, that darn user, if it wasn't for them to break my code, they make my job so much more difficult. I have to do validation. It's terrible. Yeah, I know. It's part of it. But at the end of the day, that's what it is. It's like, we have to think about, if the user can break our code, they're going to break our code as much as possible. They're going to do whatever. If your code can be broken, it will be broken by the user at 90% of the time. So that's one thing to note. So remember when we go back into the interface in a second, that whenever we get any input from our interface, it's 99%, it's a string. We have to convert it or cast it somehow, parse it to a float or to an int or to a double or to whatever we're expecting. Okay, things to note. But let's quickly talk about MVC a little bit. So we're going to deal with the MVC structure, the MVC paradigm, if you will. And MVC is really a software design pattern. One thing I talked to you guys about very briefly last week was, and if you go up here, and if you look at object-oriented programming patterns, right? There is a book, which is really kind of interesting, that came out in the 90s, and I highly recommend this as a read for all programmers. And it came out from the Gang of Four. It was written by Eric Gamma, Richard Helm, Ralph Johnson, and John Lycides, right? So this book was kind of a definitive book that we've been using in object-oriented programming for a while now, and it described 23 design patterns. Now they give, kind of examples in C++ and Smalltalk, but for the most part, all of these design patterns, there are 3 different types. They've categorized them in 3 different types in the book. Again, a little old, 1994, but still valid today. Are creational, structural, and behavioral design patterns. So creational, structural, and behavioral. And I challenge you at your time at Georgian, right, to learn as many design patterns as possible through your courses. And your instructors are going to touch upon them, very, very briefly. But these 23 design patterns have been extended, and a lot of the stuff that you're going to see out there when we do things they come from these successful design patterns. So why design patterns? When we did object-oriented programming, these authors noticed that there were some repetition. People would try and do something over and over again, and they tried to put together some convenient and conventional methods in order for you not to try and reinvent the wheel again when you're trying to do something in object-oriented programming, but rather something that is pretty standard. So let's take a look at creational patterns. So creational patterns, things that you might have heard are the factory method pattern. The singleton is something we may touch upon today. We'll talk about that a little bit, and others. There are structural patterns in terms of, basically class and object composition. And behavioral. And if you notice under the behavioral pattern, there's one called an observer. The observer pattern is the pattern that I just spoke about just now, really briefly, before we move to MVC. Let's go back to that idea. So I said that whenever we have some kind of event handler, way back at the top, I said we were talking about event handlers. And the event handler, really, if you think about what that is, event handler, event listener, is just a type of, or it's basically using kind of like the observer pattern. When the observer pattern, what it does is it creates, it's the ability for us to observe something called an observable, which would be the button or object that you're going to click or you're going to modify. And then you will respond to it. Take a look at this when you have a chance. Again, this is for your own enhancement, if you will, your enrichment. Take a look at this. Again, if you can download or buy the book, I think it's a pretty good read. It's difficult to look at, but I think it's kind of something that you may want to take a look at. Again, we'll touch upon design patterns as we go forward in the course a little bit here and there, because object-oriented programming without design patterns, it's like we're, like I said, reinventing the wheel. So observer pattern is something that we're looking at there. And when we think about something, what we're really trying to put together, when I'm kind of creating almost like this dependency structure with my model view controller. So my model view controller, really, it's a separation of concerns, or a decoupling, if you will, in some ways, a decoupling kind of pattern. And that's what it is. And if you think about it, and again, it comes from one of the 23 design patterns, and I'll talk about that in a future date, like I said, when we talk about design patterns a little bit. But really what it does is it says, hey, listen, can we not separate out all of these piece parts together? Right now, a lot of times, you can see this a lot now on the web. The web has some great examples of the model view controller design pattern, where we have the view, which is your web page, right? You have your controller, which is your JavaScript, and then you have some kind of model class, that's typically what it is, which connects to the database. That same pattern applies here in Java, especially with JavaFX, and with a lot of other frameworks as well. Okay, so you think about the user, right? What they do is in the view, and a view would be any kind of user interface. For example, JavaFX user interface gives us a view. User input, we input some view in a text field, let's say. That text field might, and maybe we press a button, like a submit button or something else like that, right? That button basically generates an event that requests data from the controller. And typically the controller is just a controller class, think about it as the logic behind the view. That's typically what I look at it like, okay? The logic behind the view. And the controller class, what it does is it takes the data and it kind of connects with the model. And typically the model will connect to a database or some kind of other data store. In the future, we're going to be working with this structure more. Today, we're not going to do a full model view controller. We're actually going to be just doing a view and a controller because there's really not really a model yet because we don't have any database to connect to. But in the future, we're going to be connecting to a database, and the model is going to produce a class and a series of other adapters that we're going to be using to connect to our database, whether it's local or whether it's remote. Okay? So let's suppose in a perfect world, so user input, requests data, manipulates the database returns the data to the controller massages it or does something with it, formats it, and then updates the view. Okay? And then the user then sees the data in the view and can use that data. That's kind of like a full, kind of a return trip, or we kind of make a request from the controller, and it returns the request with some kind of response, request response. Okay, and you guys have seen this pattern. Like I said, if you've done any kind of web programming at all, it's the same pattern. And why is it the same pattern? Because it's successful, right? So we go through these different layers, and that's what they are. But each layer is decoupled, which means I can have a set of developers working on the view. They can make a beautiful user interface. I can have other developers working on the logic behind the view, how to make that view or enable that view. And then I can have other developers that are working on the model and the object relational mapper, some kind of algorithm that connects with with entities, let's say in a database, whether it's MySQL or whether you're using SQL Server or MongoDB or some other server on the back end, some kind of wrapper or a database schema, a table schema, like for example, that describes the table itself that it's connecting to. So really kind of interesting the way it works. And we're going to be working with this idea through the entire semester. Okay, model, view, and control. Questions around this stuff a little bit, if there's any questions. Yeah, I'm sure have you guys done MVC at all here at Georgian yet? Maybe you have. Hopefully you have. ASP.NET, awesome. So was that with Rich, if I'm not wrong, Nitin? I think Rich teaches ASP.NET. Yeah, he's pretty good. And he would have taken you through the whole gamut of, kind of that whole thing. All right, so that is, okay, so Dia, you had Nital. Okay, that's fine. So really, when we think about the MVC design pattern, then, if we think about it, we have our view, and behind the view, let's say, for example, if our view looks like this, right? And everyone has by the way, just as a side note, every developer has a different way of constructing the MVC pattern, okay? For me, I personally like constructing my view first before I do anything else. Once I construct my view, and again, it really depends on how you want to do this, right? But I typically do my view first, and then I do my controller, and finally my model. I know that Jarrett, another colleague of ours, he likes to do it the other way around. He likes to do his model first, so basically creates the database first, and then the controller, and then the view. He does the MVC in that order, or he does the model, the view, and then the controller. He does it in MVC format. I like to do it view, I like to do controller, and then model. So at VCM, that's how I do it, almost like in a backwards order. And the reason for this is I find that first, if you do the user interface, that's the first thing you should do, the user interface. So think about what the user needs. That's what I always think about. Before you make any kind of data anywhere, if you're going to make a brand new system, what does your user interface look like? All right? Because without the user interface, really at the end of the day, it doesn't really, it's almost like the user interface informs everything else for me, right? It's the user experience is the most important piece. And then everything else comes from that. Again, you can decide to jump off from any point you like. But for me, I go view, controller, model, believe it or not. All right, that's how I usually do it. Or sometimes I go view, model, and then controller. But I don't start off with the model or the controller. I always start with the view. And that's what your assignment 1 is going to do. I'm going to ask you to create your view, okay, with very little logic. behind the view. So your view will work as an example, but in terms of all the full functionality, the second piece that you're going to get in assignment 2 is going to add functionality to the view. That's what I'm going to ask you to do. So typically that's how I break things out. I do the view first, and then everything else comes after it. Okay? And it really depends on how detailed I want the view. I might just do the view in the controller first, and then I do the model and the data, the database access later. It really depends. Like for example, if I want to do persistent data, I might add that in a second release, which is your assignment 2. Okay? Or with assignment 3 and assignment 4, it's going to be the same idea, where your assignment 3 might be the user interface, and your assignment 4 might be your persistent data, whatever that's going to be looking like. Okay? So the MVC pattern is treated differently for different people. All right, before we move anything else, any questions around MVC? We talked really high level about JavaFX, and I wanted to do that with you guys so that you guys have kind of an introduction or a review, a refresher, if you will, on those kind of things. But what I'm going to do now is I'm going to move right into IntelliJ, and then we'll take a short break probably around halfway through. So typically what I like to do is go for about an hour to an hour and a half, and then I take a short break, and then we go back and finish for the second hour and a half. Typically that's how I like to do it. Sometimes we do it in 3 parts. 2 or 3 parts is okay. So if there's no questions, I'd like to move right into coding at this point, and let's go right into IntelliJ. So please launch your IntelliJ from last day. And I want to talk about this. I'm going to review what we did last day, so I'm going to go right into in-class exercise 1 and talk about it just a little bit before we create our new project. Okay, so last day, what we did was, just as a review, for those people who weren't here, we had a couple of classes that we created. Let me just go back in here and close these off. So we did a very, very high level project. We had a main class, right? And the main class, really, all it was is a container class. That's what it was. And the main class had one public static method. So again, please, if you haven't had a chance to do this, bring this up. And by the way, remember that I'm also sharing my stuff with you on GitHub. So if you go to github.com/Georgian College, right? Georgian College, that is the link for my general GitHub repo, the entire account. So this is the entire account for everything we're going to do. And last week's repository is COMP1011. That's how I normally label it, the name of your course. M2022. So that's the summer semester 2022. And then in-class exercise 1, which is your lab. So that's the one that we did last week. Okay. So you can always look there if by any means you weren't here last week, or you missed, or you didn't understand something, or you don't have access to your data right now. You can always look there, and you can look at it. But let's get back to IntelliJ for a second, just as a review. So what we did is we had a main class, and the main class we mentioned was a kind of the entry point for the entire application. That's what we did. And we also had a Vector2D class that we created. We're going to reuse this class today. It was very simple. I talked about a couple of things. One of them was some conventions that I'm going to be using when I code. One of them was M_, where M stands for member variable and underscore is private. I talked about private member variables or private instance members, as well as we also talked about public properties, which are getters and setters. And getters and setters, I also mentioned that they're called something else. What did I call them also? There's another name for getters and setters. I called that, I talked about that with you guys last week. What did I say what they were called? You're awesome. So Ken, you said, accessors and modifiers. Well, so that's pretty cool. So it's actually accessors and mutators. Thank you. Dia said it right. But modifiers are okay to say too, because that's what they do. They modify stuff, but they're actually called, for the most part, most places call them accessors and mutators. So get accessors or set mutators, all right? That's what they are. That's how they combine. So that's kind of cool. And so we have some getters and setters. These are the getters and setters here. And you can see what's happened is when I opened up my IntelliJ project again, IntelliJ kind of put it all on one line. Okay, that's what it kind of did for us. So it kind of compressed the file. And if you can expand it if you want to, or compress it so you see it in one line or not when you reopen up your project. Okay, so that's one thing it did. The other thing I did was I created two constructors. I created one that was the default constructor. The default constructor, remember, going back to it, default constructor has no parameters, right? And if we create a vector 2D object, in this case, or a class, with a constructor that is not the default, which means it takes parameters somehow. Here we take a parameter that has float x and float y, right, for the vector 2D class. Then because I have a constructor that is not default, that means either I have to create the default constructor for myself, right, if I want to use it, or because this vector 2D default constructor does not exist. Remember, it's default only if I don't have a parameterized constructor. Here I do have a parameterized constructor, so I have to create this one. Okay, if I don't, and if I try and use a vector 2D object like this, it won't work. Okay. So scrolling down, I also created a couple of methods. I created an add method where I can add a vector 2D and a subtract method. We didn't really use those. I also overrode the built-in toString method, and the built-in toString method will just return a vector 2D. So that's what I've done with my vector 2D class. We're going to add more functionality to this for us, Nick, for today, because we're actually going to use this vector 2D class inside of our application. We're going to make a JavaFX application, a very simple one that's going to, kind of do the distance calculation for us using our classes, which is kind of interesting to do. All right. We also had a very simple utility class, and the utility class, it's basically using two static methods. So we have a static method that is that returns a float, and the method's called distance. But this method signature, remember what the method signature is? The method signature is the return type as well as the parameters that it takes. Okay. So the return type and the name, of course. The name is also part of the method signature. So the name, the return type, and its parameters. Those, for the most part, that is the signature of each method, right? So when we think about this then, so if this returns a float, so does this one. They're both named the same, but the difference between the two is this one takes in a vector 2D that's called start and a vector 2D that's called end. But whereas this one takes in 4 floats. Okay, so that's kind of two different ways of getting the distance, where I have, kind of x1, y1, and x2, y2, and we used a very simple equation where we had math square root. We took the difference of x's, multiplied them by the difference of y's, and then we got the square root of that to get the distance as a floating point value, okay, between the two vectors. So can you please show the functionality of distance when the variables are float? You mean this right here? How do you use that? Okay, sure. So what we did last day, and again, I'm just bringing this up so you guys can see it. So how would I use it? Well, let's suppose that I want to calculate the distance from point 2 and point 3, right? So this is the way I did it last day. Let's just comment this out for a second. Let's do another distance. Let's suppose I did it what you're saying, Dia, right? So we're going to say float distance. Let's do that. Is equal to utility. Let's call the utility class dot distance, and we'll use this one. We'll use float, x1, y1, x2, y2. So how do I get the x1, y1 from a vector? So notice I have between point 2 and point 3 is what I want. So point 2, right, is here's the x and y, and point 3, here's the x and y. How do I put that in here? What do you think I should put in here, Dia, since you're asking? I want to use point 2 and point 3 for here. Well, I'll start you off. You can start by doing this, point 2 dot, and I can do a get x, right? And I can do point 2 dot get y, right? followed by 0.3 dot get x, and then 0.3 dot get y, right? Isn't that right? Does that make sense? So you could do it this way as well. And let's see if it works. So again, this is the alternative using the second method. Dia, you asked for it, here it is. And if it works, let's see, let's run it here. So I'll run main, and let's see what happens. Let's see, does it work, right? And there it is. So you can see that the distance between 0.2 and 0.3 is 42.4264. Okay. Okay, Nitin, thanks for that feedback. But so again, you can use it in either way. And why would I want this? Because there's two different cases. As an example, maybe if you think about it, right, maybe there's going to be a problem that I might have to solve using this way of doing things, getting data this way, or there might be a problem I have to solve getting data just by these two vectors. Maybe I don't have the two vectors and I want to create them, right? So both of those two are using the two different distance methods to do the same thing. So that's an example of what? What are these two things called? If I look at the utility, right, and I have two of these, what is this called? Using the same, a function or a method with the same name, different signatures. What's that called? Kahearn says overloading, and you're correct. Yeah. Overloading is correct. Yeah. And if you think about this overloading, we did two things. We did overloading, and in the Vector2D class, we did overriding. Overriding is us rewriting the method that has been created from us in our superclass. In this case, the super duper class of Java was overridden. The toString method exists for all classes in Java, and we overrode it, right, by making our own toString method inside of our Vector2D class. So that's overriding, and that's the difference between overriding and overloading. Okay. So we talked about public methods and public properties and public objects, and I've talked about private. What about protected? What does protected do? Does anyone remember that? Let's talk about that a little bit. What is a protected method or variable or property? What is that? Why would I need protected by any means? Why do I care about that stuff? We have public and private, and then we have protected. Why do I have protected? So, I hope I pronounced this right. Ogenmaro says allows access only to extended classes in the same package. Okay. Kuhen says not to be globally accessible, and Guillermo says not access outside the class. Nitin says can't access by other class. So private you can't access outside the class. Protected allows you to access for any subclass can access it. So if I have a superclass or a parent class, and then I have a child class, if I make a property or variable or method protected, that means that only the child class can access it, but nothing else outside of that ecosystem can, right? Exactly. And I think, Chetan, you said it correctly. Only the child class can access it, all right? So it's a little different than private. Private means nothing can access it. Only the class, only members of the class itself can access it. Protected means members of the class itself plus its child classes. Okay, that's what it means. All right, so that's something that we might need to use. One thing to note is this. I will caution you against using protected. I recommend mostly that you would use public and private. We also talked one more thing last. There we go. We also, I have to, again, Amaro, because I think you said it right as well. So let's go to the diagram for 1 second. Okay, so we talked about a little bit about classes and objects, and here's my little whiteboard that I'm going to use. So here's something to note also. Here's something peculiar that we're going to notice. So let's say, for example, we talked about this briefly last week as well. If I have a parent class, which also can be called the base class, right, as an example, what else? What other names can we call a parent class? So we have a parent class, a base class. What other names can we give it? Give a parent class as well. Again, this is object-oriented programming. Superclass. There we go. We mentioned that already. So superclass as well. So those are the kind of three things we can call it, right? So if that's the parent class, notice that the parent class or the base class or the superclass, it all kinds of means the same thing, right? Okay, tomorrow, I got to give it to him this time around, right? But what about the child class? Is the child class, do you think the child class is leaner or fatter than the parent? And tell me why, if you're going to say one way or the other. And I want you to think about it. Okay, so we think about it's fatter. Why is it fatter, Kuhen? What are your reasons for it being fatter? Fatter because it has more details. Okay, that's Guillermo. More fields, again, tomorrow, methods. Okay, cool. It's all correct. It can access the members methods of the superclass. Yes, but the real reason why it's fatter is, you guys have mentioned it before, is because if you think about it, let's make a child class. All right, so let's make a child class. We'll make it look fatter too. All right, and that's again not always the case in real life. You know, parents are usually fatter than their children. But like I said, if you think about this, when we draw a diagram, a class diagram like this, as an example, with an arrow pointing up to the superclass, and let's suppose the superclass is the person class, okay, as an example. All right, so here's the person class. And, you know, I'm not going to draw a UML diagram here necessarily. And let's say the subclass, okay, the subclass is the student class. Here's the student class. Right, so here's one subclass of the person class. Well, the student class is fatter than the person class because it has everything the person has, but also more specialization. It's more specialized. So typically the subclass, so it's called the parent class or the child class. So we can call it child class. We can also call it the subclass, right? What else can we call it? The derived class, right? Derived class. There's lots of names, but it means all the same stuff, right? So child class, which is the subclass or derived class that comes from the parent class, base class, or superclass. They all mean the same things, guys, right? For the most part. The reason why this is fatter is because it's more specialized. That means it has everything, it inherits everything from the parent class, everything from this class, plus, like you guys said, all of you said it, it adds more methods and properties and everything else. And therefore, it has a larger, fatter memory footprint. That's the thing about it, right? So now let's think about this. If I made another class that inherits from student, let's say, for example, down in here, and we'll talk about this really briefly, but I wanted to talk about this just so that you guys get it. Here's another class, and I'm making it really big. It doesn't have to really be that big, but let's suppose it's something like this. It's a little bit wider than the other ones, but not as tall. And let's call this class the international student. So international student extends. We can say that it extends, or it inherits from student. Student inherits from person, right? Because international students has an is-a relationship, right? Is-a relationship. All of them have that with the prior class, with the parent class, right? So international student is a student. Student is a person, okay? Person is a class, right? That kind of thing. So they all have an is a relationship with each other. And international student is fatter because, again, it's more specialized than student. Maybe they have an international address, plus they're in residence. They have other things that the regular, maybe like the base student doesn't have, the base class, right? And even domestic student, we can have another class over here that's domestic student that is also different than the international student, but has some commonalities. Maybe they all both have student numbers, right? They both have, classes that they attend, and so on. So here's something else. What about courses? How does courses, if I make a course class, so here let's make a course class. So here's courses, right? So course. If I make a course class, and again, this is just review. You guys should know this, the course class. Does person, student, or international student inherit from the course class in any way? What do you think? Should I inherit from that, the course class? What are your thoughts, guys? Should I inherit from the course class? Course meaning, like, for example, you guys are taking COMP1011. Students have some kind of relationship with courses, right? By the subject they have. No, because the student is not a course. Excellent, Guillermo. That's exactly it. So we can't inherit from it, but we can use it. And that usage, let's say, for example, all students have a list of courses that they're taking. So example, we might have a list of courses, we'll call courses, right, that the student is taking, right? So all students have that, a list of courses, right? And that is a different kind of relationship. What relationship is this? What am I doing here when I'm using a, the course class to inside of my student class, okay? So this is not inheritance. I'm not inheriting from it. There's no arrows here. I'm just going to use it. What am I doing here when I do that? It has a relationship, yeah, but what am I doing? What is this called when I use another class inside of my class? What am I doing? I'm doing something. Hopefully you guys can get the terms, because I'm gonna share this with you now, because I'm going to be talking about this as we go forward, and I don't want you guys to be confused by what I say, the terminology. I want to get on the same page with you with terminology. So I may not just have courses. I could also have professors. There's something else I could also have. A list, each course, right, could have a professor. So professor, right? The course would have a professor, right, attached to it. Each course would have a professor, and a professor could actually be a type of person as well, couldn't they? Hopefully you guys consider professors people, but let's just say you do. So there's a professor class, right? And there's different kinds of professors too. But let's suppose here's my professor class, and let's suppose my professor class. I'm just going to make this a little bit more complicated as I create it in my diagram. Or let's say my professor class also extends or inherits from the person class. So again, Amaro says containment. Nope. It's, some people said nesting, an interface. Nope. It's actually called composition, right? So that is the term that I'm looking for, composition. So I want to compose a class. I want to compose a class, right, with other classes, right? I'm not inheriting here. I'm using a class, inside of this class, right? And this composition is preferred over inheritance. And the reason why composition is preferred over inheritance is because, if you think about it, inheritance creates more and more and more fatter and fatter and fatter objects. And there is a curse related to inheritance, where if I change something in the student class, anything else that inherits from student also breaks or changes. And it's a cascade of changes that goes down the pipe. And that is a challenge. The other thing is, of course, we mentioned it, the larger memory footprint is definitely a negative to inheritance. So inheritance is awesome because it makes it easy for us to kind of establish business rules, but it's also negative, especially depending on the kind of software you're writing, because it has a larger memory footprint and you can have breaking changes. Composition is always preferred if I add kind of objects, or if I compose objects by adding other objects to them, as an example, it's preferred over inheritance. And for the most part, because it creates a leaner class hierarchy. One thing also to note is when we compose our classes, you and I together, we got to think about commonalities. If I'm making a class, student, right, and I'm thinking about other subclasses, international student, domestic student, as an example might be two, and there could be other versions, even further specializations of international student, right, that we might think of, or domestic student, different kinds of domestic students as well, that we might think about, different kinds of professors, right, as an example, then again, if we're looking at this analogy, then we want to look at commonalities, things that both students and professors both have. Well, both students and professors, guess what? They're both people. So what does that mean? They both have names, chances are. They both have an age, chances are. That we have, there's something that people have. They probably need to eat, and some other things that are common between the two, objects. They have, if we're looking at this business example, right, then both professor and student are related, right, in that they have a common ancestor, the person class, right? But in terms of, is a person a student, is a professor a student? The answer in this case, the way we've drawn it out, is no. But here's something else. What if a professor can be a student too? Because you can be both a student and a professor at the same time, right? Example, you are a PhD candidate, as an example, but you're also, so you're a student, and at the same time you're teaching, so you're a professor. Isn't that possible? How do you do that? And that's where things get a little muddled with this example, because you're both a student and a professor at the same time. And one thing that we cannot do in Java is we cannot use multiple inheritance. Okay, we don't do that, but we can do something that you guys mentioned earlier on. Guillermo mentioned an interface. You can use interfaces instead of inheritance. And the way interfaces work is you create a contract. Remember, we talked about this very briefly. I think you guys have talked about interfaces, polymorphism. Have you guys talked about polymorphism in your previous course at all? Yes, awesome. Okay, that's good. So polymorphism, when we think about that, uses interfaces, and it also uses things like abstract classes. And what we want to do with polymorphism is we want to say that we make a contract between the interface. If I implement an interface, I say I implement an interface and I extend a superclass, right? I extend my parent class, right? So if I implement the interface, whenever I do that, I also have to include its methods. It's, I must override the abstract methods that are, mentioned in the interface. That's what I have to do, right? So that is something that is very different. And you can use interfaces here so that to say that, yes, I'm a person, but I want to construct another kind of class that uses both I'm a professor and I'm a student. Instead of making student and professor classes, maybe I can use student and professor interfaces, right? So I have, I professor and I student. And if I add those two interfaces to another class, as an example, maybe I'll call it something else, right? Then I can be both student and professor, as an example. Okay, so that's kind of a little bit of an overview just to talk about it, because we want to talk about composition over inheritance as much as possible. All right, back to the code. So now that we've talked a little bit about theory, hopefully you guys got a little bit of that. One thing we wanted to talk about here is, so we have these two things, and I want to bring these into my new project. So let's go and file, and I want to close my project, and let's start a brand new project here before we take a break. So I want to go to new project. And before we chose, a new project that uses the Java language, all right? But that is using the regular Java template. What I want to use, instead of doing it this way, is I want to click on JavaFX. So that is the template that I'm using now. All right, so there's different templates, or what they say, generators. Okay, so what is my project going to be called? Well, you know it. It's going to be called COMP1011 in the summer 2022 semester, and it's going to be called ICE2, right? Which is what we called it before. Here's something that we can do. Notice that there is a create Git repository along with it. Let's click this before we move on this time. So let's click create Git repository. You should have that option. Notice here I'm using OpenJDK 15, but I also have access to OpenJDK 17 and anything else that you've downloaded in the past. So if I say I want to use, another version, let's say I want to use OpenJDK 17, I can do that. I know there's also other versions that you can download. For example, OpenJDK 18 or whatever, you can do that as well. It's really up to you what you want to use. So let's say I want to use OpenJDK 17. Let's just say, okay? And notice how this is spinning. Why is it spinning, guys? Why is it spinning? If I chose 15, is it going to spin? Yep. How about if I chose 15 Java version? It's always going to spin. As soon as I click anything else other than the original one, it's going to spin, right? And it might also ask you you can also download a JDK. If I click download a JDK, you can specify which one you want. For example, if I want to download version 18, I can do that, okay? I'm not going to do that here. I'm just going to go with 17 or 15. Doesn't really matter here. But let's go with 17, and I'm going to click Next. Notice also, before I click Next, I can choose a different language. I can choose Java, Kotlin, Groovy, and there's different build systems. Remember I talked about that JavaFX is not included by default with Java anymore, right? So I want to include it. Before also I do that, the group is important. I want to kind of mention it like this. We'll say ca.georgian college, right, is going to be our group. Okay, so please use ca.georgian college here on in when we make any kind of JavaFX or even later on Android. If we make an Android application, we're also going to be using the ca.georgian college. Usually we use reverse DNS order, right, in order for us to create our package signature or bundle identifier is what we're actually doing here. Okay, and then click Next. Now there are some lovely libraries we can use. We're not going to use them today. We may explore them at a different time in the future. But for example, Bootstrap adds some CSS and so on. We're not going to do that today, but maybe in the future we'll add some of these libraries. And we're going to leave these unchecked and click Create. Let's do that. Okay, let's click Create. So what Maven is going to do, Maven's a build system, and you need to let it do its thing for a second. So what it's doing here is it's doing its build. Give it a chance to do that, okay? So don't do anything yet. Just click Next and let Maven and everything do its business, okay? And you got to wait a bit because it says here, so how it says downloading dependencies is doing that. And it's important for you to do it because what will end up happening is if you try and run it now, it won't run properly. This just doesn't work, right? So give it a chance to finish. And when it says sync, you're pretty much good to go. Okay, so hopefully you've done that. On the right, notice that there is Maven that's already here on the right. You can see that it has all the dependencies that are here. Added in all of our dependencies for OpenFX, for JavaFX controls, different plugins that it added in, all these things that it did for us. Inside of our lifecycle, it kind of created lifecycle objects as well. All that stuff that it did, we did nothing around that. So that's pretty cool for Maven. So that's one thing to notice. Okay, on the right hand side. Also, we're going to see later on, we're going to look at database. We're going to if we wanted to connect to a database, we might have to do it here, and we can add a data source later on. For now, we don't have to do that, but notice the controls in IntelliJ. Don't ignore some of the stuff that's here. There's a lot of really cool controls that are included in IntelliJ without you having to do much of anything, actually. Okay, here's what I want to do now. I want to run this class. And last time what we did was we created a configuration by going to build project. But here I'm just going to go click on this like kind of a play button inside of my hello application. Now here's something to note about this, okay? If I look inside my source, notice that there are two, inside of main, there are two folders. There's Java folder and there's a resources folder, okay? So a Java folder and a resources folder. And in the Java folder, we have in Java, we have hello application and a hello controller. We're going to change this later on. We're going to call it our own controller in a second. And then we also have a hello view Fxml. All right, so this is kind of what you come with when you start off, right? So we have two things, and it was all created for us. Again, a very different layout than what we had last day, right? We had Java and we have resources. And we're going to look at both of those two things. The other thing is that both of those two things have our bundle identifier here. So ca.georgiancollege.comp1011 M2022 ICE2, both are there as a bundle identifier. So that means it's in the same package, which is pretty cool. All right, so we don't have to look outside this same package for us to do that. What does this look like on the operating system? Okay, because remember, this is in up on top here. You can see that it's in C users, you know, me, OneDrive, desktop, Georgian, COMP1011, 1011, M2022, ICE2, right? So one thing you can do is if I was to go up here, right, you can see that I can copy path or reference, right? And I can do two things. I can copy the absolute path, right? So I can do that. So that's Control-Shift-C, right? And the reason why I want to do that is if I bring up my File Explorer window, and I can just then, what I can do is I can just paste that in, right? So if I paste it in, it'll quickly teleport me right there. It'll change directory right into that folder. So that's something we're going to be doing today a couple of times, right? So please make sure that you see that. So at the top right of your project, you can see that that is something we can do. And notice in here, we have a couple of hidden folders. Now I can see my hidden folders because in my view, again, if you're using Windows 11, it might be slightly different. But if you're using Windows 10, you'll see that I'm showing hidden items as well as file extensions. So please make sure you check those two things on. In your Windows 11, you'll have a very similar thing for your view. You'll have a view menu, but you'll have an item list to select. Okay, so please select file name extensions and hidden items so we can see them. And so you can see that we have a hidden.git folder that was created for us, as well as an idea folder, which is created by IntelliJ, MVN folder that was created by Maven. Okay, so those three hidden folders are required for your project, plus a gitignore file that was created by IntelliJ as well. So really cool stuff that was done for us, and right off the top. Okay, excellent. So why do I care about this? Well, because if I look inside of my source, inside of main, so I'm in source, main, and then if I go here, you can see that there's Java and resources. If I look at Java, well, this is interesting. It's got Java, CA, Georgian College, and then the module. So it's like, even though it's mentioned, it looks like this, CA, Georgian College, dot, blah, blah. It's actually a series of folders. All right, that's one thing to note. So in the operating system, it's laid out a little bit different than it's laid out inside of your project folder. Please make a note of that before we go on. And why am I mentioning this? Because people get confused. They're like, wait, my File Explorer looks very different than this. Well, yeah, but it's only because your packages are kind of aligned inside several folders deep. That's how it works. One thing also to note is in the project, you can also look at the right here, and you can see that there is an option for tree appearance. And my tree is looking like this, compacted, because in my tree appearance, my default is compact middle packages. So if you don't have this checked, you might see a very different view than mine, okay? So please, my tree appearance, again, I clicked on project. I went to the little gear, and you can see here, I just chose compact middle packages so that it doesn't show that. It's not going to change anything on the operating system side. It's just going to change the way it seems in our solution here. Okay. Excellent. Let's run it and see what happens. So if everything goes well, if I run this thing for the first time, right after I've waited a little bit for Maven to do its work, I get this. And notice that when I get this is obviously not what we want for today. But if I get this and click hello, well, look, there's even an event handler that's built in where it says, welcome to JavaFX application. Huh. Wow. Okay, that was interesting. Nice. So this is kind of neat. And one thing to note is that is our basic template. On the left, you can see that there is two parts. Like I said, the Java part, which includes my hello application. That's my starter. my entry point, if you will. And there's also my hello controller. My hello controller, if I double click onto it, you can see that it's kind of weird. It has a class like a container class, and it contains two things: welcome text, which is a label, and an on hello button click event, which basically says when I click on this button, it's going to set text. I kind of mentioned that inside my PowerPoint, by the way. If you look at the label inside of my PowerPoint document, it says you can use the set text method, right, in my PowerPoint to set the text of a label, right? So it says welcome text, set text. Welcome text means this one, this object right here. Welcome text, set text to something like welcome to JavaFX. That's what it does, okay? So that's what the hello controller.java does. We're going to modify this, make it our own. And then the other thing we have is a hello view Fxml. Of hello view Fxml, remember we said that it's XML and it looks declarative. So we have a VBox. Here's our VBox right here. And inside of our VBox, we have some padding, a padding object with insets, okay? And then we have two things inside of there. One of them is a label, which is called with an ID of welcome text. Notice that this welcome text ID matches the one that's inside of the hello controller. Right there it is. And it also has a button. Here's our button that has some text, which is kind of like an embedded label. So the hello button. And it has an on action method, which is kind of like an event listener that basically says, hey, if you click on the button's action, which the default action for a button is a click event, right? Then what do I want to do? I want to activate the on hello button click event. And notice we're using a hashtag to start that off, right? Which means in the hello controller, I'm just showing you how this works, we're going to use the on hello button click event to trigger whenever I click on the button. That's what it does. Okay, so I want to talk about this just because so you know the anatomy of how these three classes work. Okay, because that's what they are. They're kind of like three little classes. One of them is an Fxml document. It's not really a class, but these three little objects, if you will, that are part of my project are kind of, they work this way. But we don't want this, right? One thing also to note is this. There is a scene builder that is built into IntelliJ. So at the bottom, notice that there is text. When I'm clicking on hello-view Fxml, on the bottom there's text, and there's also scene builder right here. See that scene builder one? So if I click on scene builder, it actually gives me, if you will, a scene builder view. But in my case, and this is not untrue for everyone else, it says download the scene builder kit. Okay, so if I download the scene builder kit, if I do that, I get something that looks like this. But that's not exactly what my project looked like. When I launched it, it looked like, well, like this, right? So this and this don't really match. And so that's why a lot of times on mine it doesn't show up. Did it show up at all? Like a little thing at the top there that says download scene builder? Anyways, it doesn't matter, Dia, because for us, we're not even going to use the built-in one, all right? Here's why, okay? I'm going to talk about why we don't want to use it. One, I still think they're working to get it closer to doing this. There is no option for scene builder. Yeah, and that's an issue, right? Some people don't have it. It really depends on your version of IntelliJ and all that kind of stuff as well. And some people, again, the only way it's going to have it, Dia, is if you're clicking on the hello view Fxml and you've got it open. So if you double click on hello view.xml and you have it open, and then there's a text and there should be a scene builder option at the bottom. Check down there again, one more time. That's the only time you'll have it. You won't have it for hello controller. Hello controller won't have that, and neither will hello application. You won't have that for those two. But for hello view Fxml, you should have an option for that, okay? The challenge is this is no good. This is not what we want because it's not a one-to-one representation. A lot of times we used to call it WYSIWYG. I don't know if you guys remember that term, or if you've ever heard of that term. WYSIWYG means, what you see is what you get, and it's not what you see is what you get. What you see here is not what we're getting when we run the program, right? So this here is different than this. We have other things in here. And I'd rather see it so it's closely matched to this one compared to this one. So that's why I asked you last day, although it's here and built in, you could use this if you wanted to, but we're not going to. Okay, we're not going to use this one. Instead, what we're going to use is the third-party version, which you can get by, because I've downloaded Scene Builder. So here's Scene Builder for me. I've downloaded it. I also think because we're going to be using Scene Builder in the future, right? We're going to be using Scene Builder in the future, that I want to pin it to my taskbar. So I'm going to pin it to my taskbar here so I can always get it. I'm just going to put it right next to IntelliJ so I can see IntelliJ here on my taskbar and, kind of Scene Builder here. So I can always run it when I need to. Now I want to open a project, but I don't have a project to open. I could open this one. Let's see if I can open hello view.fxml, and does it look different here compared to what it looks like in the built-in Scene Builder. So let's open a project. And remember we said that you want to put in that copy the path. Let's try that again. So I'll leave that open for a second, but I'll go over here to the top here with my project. I'll right click and I'll go copy path reference, and I'll select my absolute path, that one, and then I'll go back to Scene Builder. Scene Builder, I'll be okay. And when I click open project, I want to paste in my path like this. And so I can get right in there. Do you know what I'm saying? As opposed to trying to go through the application hierarchy inside of my file structure and blah, blah, blah. I don't have to do that. I can go into source and inside main, and I want to go inside of resources. This is the link. And I want to choose hello view.fxml and click open. And if I did everything right, hey man, it looks exactly the same. How come? How come this looks so small? And why is, when I run it, it looks much bigger? Well, because remember we said what you see is what you get. The reason why I also like this window is because it's kind of, even though it's exactly the same as the one that's in IntelliJ, the great thing about this is I can pull it around. It's separate from IntelliJ as well, as opposed to being part of it. And a lot of times I find that there's just less trouble when I use the external tool than I do when I use the internal one, the one that's connected to IntelliJ. IntelliJ is getting better and better and better every single time, every release, but I find that still I prefer my external tool. But here's the great thing about this. If I look at the Fxml document in my IntelliJ, right, it looks a little cryptic. If you were to look at this for the first time, you're like, well, I don't want to get it. I don't understand it. Great thing about Scene Builder is it's visual, right? So it's drag and drop. On the left, you can see that there's a hierarchy, which we talked about in the PowerPoint document. So in the PowerPoint, I said, we're going to be using Scene Builder, and it's going to have a hierarchy that looks something like this. So that's what this hierarchy is down here. This is the hierarchy that I talk about in my PowerPoint, right? And notice on the left, you have, if I click onto it, on the right, you have a context. Again, guys, if you've done this before and I'm boring you, forgive me. I'm just trying to bring everyone up to the same page as everyone else. If you've done Scene Builder before, fantastic. If you haven't, okay. But notice here, it's an inspector. There's properties. There's 3 little collapsible accordions, if you will, that are here for each thing that I've got here in the hierarchy. I'm looking here at VBox. At the top of VBox, you can see that there is a properties accordion, which has all the properties that are available to me to program, right, inside of my Fxml document. So for example, the alignment of the VBox itself, which is the vertical box, is center. My node creation is inherit, and there's a bunch of other style. I can also, target a style class or a style sheet if I want to, which is something I can do, as well as attach an ID or do a bunch of other stuff here, okay? Same thing for my label. You can see that the label itself, if I click on the label, on the right-hand side in the properties, you can see that the label says welcome text, and welcome text is actually, if you go to code, right, if you open up that little collapsible area, that is the FX ID. We're going to need to do this FX ID when we create our user interface for our vector 2D calculations. That's what we're going to do here. So here's our label, and if you notice, button does not have that. Button does not have an FX ID. It doesn't require it at all. But here's something that it also has in here. It has on action. It kind of picked that up. On action, on hello button click is right here, right? So that's kind of how everything works in my project. Let's close down. I'm not going to use this. I'm just showing you how to connect to it. So let's close down Scene Builder for a second. Now notice that again, I've saved it here on my, I've attached it to my, my bar here, my quick bar. And what I'm going to do here now, before we go for a break, because I know we're kind of it's time for a break, is under the CA Georgian College COMP1011 M2022 ICE2, I'm going to right click here and I want to click New. And notice I have some options for stuff that I can add here. I want to add a brand new Fxml file, right? And the Fxml file, we have to kind of create it in this fashion. And what I want to do is calculate my distance, right? Calculate distance is what this thing is going to be called, right? Because that is what I want to do, right? And I can be very specific, right? So I can say something like calculate vector 2D distance if I really want to. And sometimes you want to do that for each of your scenes that's inside of your, that's on your stage. So you start typing like this, calculate vector 2D distance. That's my Fxml document. That's what it's going to be called. Calculate vector 2D distance. Okay? And click OK. And what this does is it says, do you want to add this following file to Git? And I'm going to say, yes, I do. And notice what it does is it creates an anchor pane, which is kind of neat. There's my anchor pane. And, well, it's looking for a controller class. Take a look at that. It says calculate vector 2D distance. It's red like this. And well, whenever we see a red thing on IntelliJ, it usually means that something is missing. Okay, something is missing. So what I want to do here is just like I have this hello controller, right? So if I look at the hello controller, which is a controller class like that looks like this, right? I want to kind of do the same thing for my controller class, right? Where I want to make a brand new class. So it's a Java class, that's what it is, right? So it's a class. And pretty much it's going to be empty, but I'm going to call it, instead of hello controller, I'm going to call it calculate vector 2D distance controller. It's going to be really long, isn't it? Okay. And typically what I like to do, and maybe you might get into the habit of doing this as well, is make a very descriptive class name. There's nothing wrong with that because it tells you exactly what we're doing. Okay. Let's try this. So again, I'm going to right click on this part now. So the first, I added it here in resources. The second one, I'm going to add here. So I'm going to right click, I'm going to go new, and notice that it says Java class. I'm not going to add any of these. I'm going up to here where it says Java class. And up here, I'm going to make the name. It's going to be called calculate, right? Vector 2D, make sure it's 2D, capital D. Everything in the, when I make an Fxml document, it's separated by dashes. That's the default. And it also is lowercase. Here in my class, I'm going to say calculate vector 2D distance. Notice that there's two Ds there. That's okay, right? Vector 2D distance, right? And then controller. It's really long, okay? But that's okay, because now we know what it means. Maybe in the future, we might cut this down or we'll do something different. But that's something that I want to do. All right, so then if I do that, and if I press enter, right, then it's going to create that class for me. It's asking me if I want to add this to Git. I do, right? So there it is. And typically what I do when I program is I put my curly braces underneath each other like this. Guys, that's all you need to start with when you make a brand new Fxml document. Now what we can do is, now that I have even an empty class like that looks like this, calculate vector 2D distance controller, right? This one. then if I go to my calculate vector 2D distance Fxml document right here, I can, if I do the dot here like this, if I do a dot, you can see that it's going to pick up my new object. Look at it, calculate vector 2D distance controller. I can double click there, and then it will replace the stuff that was there before with my new class, and now there's no error anymore. There's no error. Okay? Save. Make sure everything is saved. I'm going to put this up on GitHub now. Okay, so, and this is where we're going to stop before we take a break. So I've created, just to recap, I've created a calculate vector 2D distance Fxml document, okay, which is this. And all it has, it describes just an anchor pane with nothing inside of it, but it also connects to an FX controller, which is right here. This is an important step. And then in order for me to make this work, I had to have an empty calculate vector 2D distance controller class that's empty inside, just so that way my Fxml document can connect to it. Okay, that's kind of a step that we need to take. Okay, and now let's put this up on GitHub. So again, Git, if you notice Git, I have on the left, I've added some files. These are all the changes. I want to click on all these changes, and I want to say added project files here. Added project files. That's what I'm doing here. I'm going to commit by itself first. I'm going to do that commit first. So I'm doing the commit. And it says commit anyway. I'm going to commit anyway. And one thing I'm going to do is I'm going to use my terminal window here on the bottom to do the rest of the commands. So I'm going to kind of clear the screen here on the bottom of my terminal. I'm clicking in the terminal right here, right? And I'm going to create my repository online. I'm going to do it this way this time. So I'm going to go up to here on Georgian College. You go on yours now. Remember, we'll do the same thing because you're going to have to share a private repository with me again. I'm going to make a brand new repository. So I'm going to click new, right? And it's going to be, this is for your in-class exercise. So it's going to be COMP1011, summer 2022, right? And it's going to be ICE 2, okay? That's what it is going to be. You're going to make it private. I'm going to make it public. Please make it private, but then include me as a collaborator. And again, please include the Tsiriopoulos@hotmail.com me, not anyone else. Please take a look at the details up on Blackboard for that. Okay, I'll make mine public. That's what I'm going to do. And then I'm not going to add anything else and just click Create Repository. It's going to give me steering instructions. I need to take these last 3 lines of code here. I'm going to copy them. And I'm going to go back to my IntelliJ here in my terminal and right-click and paste them. That's what I want to do. And when I do that, it adds in my remote. We talked about the remote last week, as well as it configures my branch name, which is main, and then it allows me to push to GitHub. Let's see if I can do that. If I press enter, it's going to push to GitHub for the very first time, and it does all that connection stuff right here. Please do that now with me and include me as a collaborator. I should get a pile of emails from you guys that you've made me a collaborator, okay? And if I look up online now, if I refresh, you can see that my repository has been created. My in-class exercise is public. Yours would be private, right? And again, to make me a collaborator, you would go to Settings, Collaborators and Teams, log in, okay, log in. And then once you've logged in, you can add people, and you're going to add me, which is Tsiriopoulos@hotmail.com. Okay, add me. Notice that there's only one me. Like if you did this address here, if you type this address in, not my first name, last name, but the whole address, and if you click me, and if you just give me read access, that's enough. That's all you have to do, and I'm good to go. Okay, that's how you do it. If you don't do this, and if you leave it as private and you don't include me, you'll lose 0.5% off your in-class exercise, okay? Because it won't be working. It's got to be accessible. All right, so, okay, that's good. And I'm going to go back to IntelliJ, and I can close off this window now. All right, so now that I've done that, remember, I can do the rest of my Git commands here or here. No problem. I can do all my Git commands here, or if I really like to, I can do all my Git commands here in my terminal. It's totally up to me how I want to do that, but I find connecting to my repository online is easier through the terminal than it is through my Git commands up here. Okay. Questions before we stop for a short break, because this is where we're going to start right now. All right, guys, let's stop for a short break. I'm going to stop sharing on YouTube. Right now it's 7:40. Let's get back at 7:50. Let's take around 10 minutes around that time. When we come back, we'll build our application. All right.